In this video, we're going to go over how to find missing angles using our trig functions. If you take a look at this top part of your notes, question 1 says, the sine of theta is equal to 0.8426. Right now, this looks a little different than what we've seen before because our angle measurement isn't given to us. So in this case, theta is going to represent our unknown angle. We also have a ratio on the other side. This 0.8426, if I think about what sine represents, I know that sine represents opposite over hypotenuse. So I know that this 0.8426 is the ratio of the opposite side to the hypotenuse of whatever triangle we're thinking about. But we don't know what angle we're using as our reference angle. So in order to find this, we're going to use inverse functions. If you take a moment to think about a similar problem, if we had a problem that looked like 4x is equal to 20. In order to solve this problem, we would use inverse operations. We'd see what's happening with the x, which right now is multiplication, and to undo it, we would divide both sides. That's the inverse of multiplication. So in the problem that we're looking at now, in order to think about our x value, we can think about the theta as our x value in this problem. So if we say what's happening with our theta, what's happening with our angle, we know that right now we're taking the sine of that angle, and we don't want the sine of that angle, so we're going to do the inverse. And in this problem, that's going to look something like this. When you have sine and you write it with this like -1 in the exponent space, that represents the inverse of sine. So we're going to take the inverse of, and now I'm going to keep everything else that we had here. So this looks just like the original part of our problem. And now I can make this equal to, I again want to take the inverse sine, so the same way that we divided both sides of our similar problem by 4, here I'm going to take the inverse sine of both of these sides. And this is just what it looks like all written out. And when we have this on the left side, inverse sine and our sine are going to cancel out. So that's why we have it all on one side. And the only thing left now is our theta. And then on the right-hand side, we have the inverse sine of 0.8426, and that's what you're going to put into your calculator. If you take a look at my calculator on the right, in order to get inverse sine, so far we've been using the sine, cosine, tangent buttons that are right here. Inverse sine is right above the sine button. And in order to get it, you hit the blue button, and that allows you access to all of the blue keys on your calculator. So you can hit second, sine, and now you're going to notice on your calculator it says sine. It has the little -1 there that indicates that we're talking about the inverse. And you're just going to type in exactly the decimal that you have on this side, close your parentheses, and when you hit enter, you're going to get your angle measurement. So I'm just going to write this down here for space. So I know that my theta is approximately equal to 57 point, I'm going to round this to 0.42. And those are the steps that you need to find the inverse. Take a moment to pause the video here and see if you can work out cosine number 2 by yourself. Okay, if you're coming back to check in, take a look at the work that I have written out for number 2. So I started off with our original problem, and the new part here is I wanted to get rid of the cosine that's with my x right now, so I took the inverse cosine on both sides. I just want you to see how we're writing it out so that you know what it looks like. On the right-hand side, now my inverse cosine and cosine cancel out. All that I'm left with is this x. And then on the right-hand side, I have the inverse cosine of 0.5431. So that's what I'm going to put into my calculator. Inverse cosine 0.5431 And you can round out your answer. It's approximately 57.1 degrees. Try out questions 3 and 4 on your own. You're going to notice the only thing that changes about question 4 is that now you're looking at a fraction instead of a decimal. When you type this into your calculator, I'm just going to show you over here, you're just going to write it in with your 3 divided by 7, just like this, and it should be inside of your parentheses. But you don't need to change anything about the way you're entering it into the calculator. Okay, let's take a look now at these inverse trig functions in context of our triangles. As a reminder, at the top of my page, I'm always just going to go ahead and write out SOHCAHTOA so that I don't forget what our trig functions are. And let's take a look at problem number 1. So right now I have a question mark in this angle. I'm going to go ahead and label that angle as my theta. I'm saying that's the angle that I don't know. If I label my sides, I know that the 55 is the hypotenuse. It's the longest side of the triangle that's across from the right angle. I know that the side that's across from my theta is the opposite. And then I know that the side that's next to the theta is adjacent. If I take a look at all of these values, the one that I have no information for is my adjacent side. So I'm just going to cross that out. And now I know that I need to be using a trig function that only uses O and H. And so I recognize that is my sine function over here. So I'm going to go ahead, I'm just going to write my workout just down at the bottom because I have more space. So I know that if I have the sine is equal to opposite over hypotenuse, when I write this out, I'm going to have the sine of theta, I don't know that angle, that's what I'm trying to find, is equal to, sorry I'm moving this a lot, is equal to 34, my opposite, over my hypotenuse, which is 55. So now, just like we did in the problems prior to this, I want to get rid of this sine, right? That's what's with my theta or with the value that I don't know. So in order to get rid of the sine, I'm going to go ahead and do the inverse. So I'm going to write it just like this so that I have sine inverse. And I'm trying to show you in different colors here. So you're taking the inverse sine on both sides. And on this side, I'm just keeping that fraction that we had, 34 over 55. I know that on the right-hand side, inverse sine and sine are going to cancel out. All that I'm left with is theta. And then everything that's on the right-hand side of my problem, I'm going to go ahead and put into the calculator. So I'm going to put inverse sine of 34 divided by 55. Close my parentheses. And my theta angle is approximately equal to 38.18 degrees. So again, when you're thinking about the steps for this, I started off by labeling all the sides of my triangle. I identified the trig function that I needed to use. I set up my trig function with all of the values that I know, and then I used the inverse trig function in order to solve. Go ahead and try those steps out on question number 2, and then check your work in a few moments. Okay, if you're coming back to check your work for number 2, you can take a look at how I set up my problem. I labeled the sides of my triangle. I had my opposite and my adjacent, so that means that I was using tangent. I set up my problem as tangent of theta is equal to 8 over 20, the opposite over adjacent. And then I used inverse tan, so that on my left-hand side here, inverse tangent and tangent will cancel out. All we're left with is the theta. And then on the right-hand side, we have inverse tan, so I'm putting this into my calculator now. Inverse tan of 8 divided by 20. So my angle is approximately equal to 21.8 degrees. Go ahead and try out the next 4 practice problems on your own. Get your work checked by a peer or a teacher, and if you have questions, come back and try out this video.